Ah!
Who are you?
See, we're from the British Ministry of Revolutions, and we're here to find really the volume of your revolution.
So you're kind of like math wizards?
Well, they do call me the math whiz.
Witchcraft.
Please, let us explain. It's not magic, it's math.
Right. So this is the case of a normal revolution. Now, revolutions normally last about from 0 to about 4 months. And while we're having this revolution, there's always going to be an increase in population, which will be represented by the equation y equals the square root of x, which will look something like this. And so since it's 4 months, we're going to cut off at 4 months. Now, to find the volume of this revolution, we're going to rotate the equation around the x-axis. And so, in order to do this, we're going to cut it up into cylinders. So we're going to find what the radius will be, which will be y, and what the height will be, which will be dx, which is the change in x. Now, since this will be rotating, it will become a cylinder. So we're going to use the cylinder equation, pi times r squared times height equals the volume. So we're going to plug this into an integral. So it will be the integral from 0 to 4 months of pi times the radius squared, that's y squared, times the height, which will be dx. Now see how there's an x and a y? That doesn't really work. So what we're going to do is we're going to look back at our original equation, and we see that y equals the square root of x. So we can just change this to, from 0 to 4, pi times the square root of x squared dx. Will be 8, so that will then be 8 pi units cubed will be our volume of this revolution. Now this is just a normal revolution, mind you. See, in a normal revolution, it starts with a lot of people, loses a lot of people, and then goes to a lot of people. So in order to demonstrate this, we're going to have to make maximums, and do this, we're going to use parabolas. Now we're going to start out by using the equation y equals negative quantity x minus 2 squared plus 4. That's just this part right here. And to stop at the maximum, which is 2, it's going to go from 0 to 2. Now to find out how it is over a period of time, equal amount of time, we're going to revolve it around the y-axis, giving us this. So first thing we're going to do is we're going to do our rectangle. Going to make a rectangle. This time, it's going to be starting on the y-axis because that's what's rotating around. The height is going to be dy, and the radius gets a little tricky because you'd think, oh, I can just do it from 2 and just be 2, but you can't because this middle part is being revolved and just making a kind of empty part of the volume graph. So what we're going to do is go 2, which is all of this, minus x. And x will just be what is in here, in between 0 and the graph. So now that we have that, we can use our trusty volume formula, pi times r squared times h, and plug that into an integral. So we have 8 pi units cubed. And that is our volume of this revolution.
Whoa!
Sorry, math does some weird stuff. Alright, so we've done our 2 revolutions, now we're going to do your revolution. So as you can see by this graph, we have a lot of people who do want to fight, but then some people down here in this empty area that don't want to fight. So what we're going to do is take this whole function, which represents your revolution, which is y equals negative x squared plus 4, and we're going to revolve that around the x-axis, subtracting this equation of y minus 1, subtracting that when it revolves around, so we can find out the volume of your revolution based on the people who do want to fight. So now, Matt, the math magician, is going to show you how to do this math. So our answer is 30.484 pi units cubed.
Wait, what's that?
What? Oh, this is just a graphing calculator. I was just doing matrices on it. I don't know how they work, but they somehow give me answers.
Witchcraft.